About 285 meters above sea level, Krakatau is believed to have been initially formed around 535 CE. Located in the Sunda Strait between Java and Sumatra, Krakatau is infamous for its catastrophic 1883 eruption. Since then, the volcanic landscape has been reborn as Anak Krakatau. Here is an image of our top trump card. The 1883 eruption of Krakatau was one of the most powerful volcanic events in history. It measured a 6 on the Volcanic Explosivity Index, releasing the force of 200 megatons of TNT. Locally, deadly pyroclastic flows, tsunamis, and ashfall devastated the coasts of Java and Sumatra, destroying villages and killing tens of thousands. Globally, Krakatau's eruption sent 20 cubic kilometers of material into the stratosphere, causing a global temperature drop of about 1 to 2 degrees Celsius and disrupting weather patterns for years. We gave Krakatau a deadliness score of 90 out of 100 because of its long history of catastrophic eruptions and its close proximity to densely populated coastlines. The 1883 eruption alone killed about 36,000 people, with over 34,000 deaths caused by massive tsunamis that swept across Java and Sumatra. More recently, in 2018, a sector collapse of Anak Krakatau triggered another deadly tsunami, killing over 430 people and injuring tens of thousands. Today, more than 3 million people live within 100 kilometers of the volcano. Many of these are low-lying fishing or resort communities with little natural protection from incoming waves. Because eruptions here often generate tsunamis without warning, and due to the region's high population density, Krakatau remains one of the deadliest volcanoes on Earth.
To analyze Krakatau's devastation potential, we evaluated 4 key factors and gave it a different weightage. For eruptive sound intensity, we gave this factor a weight of 30% and a score of 80 because Krakatau has shown frequent strombolian blasts of volcanic gases and ash particles. During stronger episodes, ash plumes can rise up to 1 km above the summit, and occasional lava flows reach the sea. The regularity makes them locally hazardous, especially for those within a few km of the volcano. For regional physical reach, we gave this factor a score of 90 and weight of 25% because Krakatau's effects can extend well beyond the island itself despite it being in the sea. The most significant example occurred in December 2018, when part of the volcano's flank collapsed into the ocean, generating a tsunami that struck the coast of Java and Sumatra. Waves several meters high damaged roughly 300 km of coastline and caused more than 400 fatalities. For global atmospheric and climatic effects, we gave it a score of 50 and a weight of 15%. We rated this 50 because Krakatau's recent eruptions have had minimal global impact. The 2018 eruption injected ash and gas up to 15 km high, but only released 0.17 million tons of SO2, which is far below the threshold needed to affect global temperatures. The historic 1883 eruption, however, had major impacts on global average surface temperature, which dropped by about 1.2 degrees and persisted till 1888. For recurrence potential, we gave it a score of 95 and weight of 30%. This is because Krakatau is still highly active and has had 57 confirmed eruptive periods. It is still active and has a VEI of 2. It also lies on the Pacific Ring of Fire, which has a tectonic setting that continuously generates intense seismic and volcanic activity, providing a constant magma supply that makes future eruptions highly likely. Therefore, the overall devastation potential score for Krakatau is 83.
The most recent eruptive period began in May 2021 and continued until December 2023. During this time, activity ranged from mild strombolian eruptions to more explosive events, producing ash plumes that reached up to 2 kilometers above the crater. Observations between May and August 2023 recorded mostly white gas and steam emissions, rising 25 to 300 meters, with occasional ash plumes drifting in multiple directions. Seismic activity and webcam images confirmed intermittent ejection of incandescent material. Despite continuous monitoring using seismic networks, satellite imagery and thermal data, Anak Krakatau remains highly unpredictable. So, we rate the unpredictability at 75 out of 100. The volcano's irregular eruptive patterns, ranging from mild explosions to sudden large-scale collapses, make forecasting extremely challenging. The 2018 flank collapse, which generated a deadly tsunami, highlighted this danger. Although long-term satellite data showed slow deformation of the volcano's southwestern flank, these signs were too subtle to predict the collapse in advance. This demonstrates that even with modern monitoring, certain hazardous processes, especially flank collapses, cannot yet be reliably anticipated. In summary, while recent eruptions have been closely tracked, Krakatau's behavior remains erratic. Here are our works cited pages.